There was a time when I told you students that if for some reason there's no solution, we will get into the answer. And here's that time. And actually in 4.8, we have two videos. This is part 1. Okay, so complex numbers. What is a complex number? It's when I have an imaginary unit. Right now, if you were to type in the square root of -1 into your graphing calculator, any calculator, it will say no solution. It's saying that that's not possible. However, we want to try to figure out what is going on when this is happening. Now, this is kind of more about abstract thinking when you have imaginary numbers like the cloak of invisibility. But this is like when, if you want to be an astronaut, when you have to try to think outside of the box. And you might be thinking, I'm not going to be an astronaut, Mrs. Frickman. It doesn't matter because the fact that this imaginary unit is in other areas of math as well. I was just giving you one example. So when I'm talking about imaginary units, I is representing the square root of -1. So when I have the square root of any negative, there's always going to be I with it. Because I can split up the negative and whatever number it is, the -1 and a. So in this case, this is the I, and then whatever this number will be. Example, so if I have the square root of -5, the negative is the I part, and I still have the square root of 5. So again, this is not 5. So when if I were to square this, when I go through these steps, and again, we'll be practicing this. So how do I write the I unit? So first I'm going to rewrite this to be square root of -1. And once you get used to doing these, you can, your work, it might not be as large, but you can do this either by um, perfect squares or by the factor tree. I'm going to do it by perfect squares. So now I have it written out because 18 is 9 times 2. Now when I write this out, typically you have your whole number here. So the square root of 9 is 3. So that's where that comes from. Then I write my I unit because the square root of -1 is I. You should write it as a fancy I of some sort, either like that or like that, so that you know it's an I and not a 1. And then the square root of 2 cannot be simplified. So this right here is my final answer. So I would like you to try to do these 3 by yourself right now. One thing here, I did it by factor tree method here, so I have a pair of 2, so a 2 comes out, and I have my square root of 3, and again, that square root of -1 is that I. Square root of -1 is I, square root of 25 is 5. One thing when you're writing this, you typically do not write it like this. The reason why is because if you accidentally do this, these two are not the same answer. So you write your I in the front of a root. If there's still a root, you write your I in front of the root. So does this equal this? Pause the video and try to figure that out. No, this has an I with it. Square root of -1 is I, square root of 64 is 8. This right here is saying -1 times the square root of 64. The square root of 64 is 8. That's -8. So those are not the same. So like everything, we have a standard form. When we write an I value, a number that represents I, we write the real part first, so any number that does not have I, with the imaginary part second. So when talking about I's, we've talked about real numbers, and then we have irrational numbers. Complex numbers are going to be looking like this. So this again, when B is not 0, meaning that you will have an I value. When I add and subtract, this is where it kind of gets easy, but sometimes people get confused also. When I'm adding and subtracting, I can add imaginary units and I can add whole numbers, real numbers. So I can combine these like terms and I can combine these like terms. So I can look at this 4 plus a -4 would give me 0. -3i plus 3i would give me plus 3 or 0i. So this overall answer would just be 0. So combining like terms. With subtraction, this is where people make this one small mistake first. When it's subtraction, you are switching your sign first. So I have 5 minus 3i. -1 times -2 is a positive 2. -1 times 4i is -4i. Now I can combine my i's and I can combine my real numbers. 5 plus 2 would give me 7. -3i minus 4i, so I'm looking at those, is a -7. And since those were imaginary, they stay imaginary. So this is my final answer. I want you to try to do C, D, E, F. So here I combine my 7 minus 3. That's where the 4 comes from. -2 plus 1 is a -1i. So that, again, has to have that I. It has to represent the imaginary number. First, distribute your negative to both. Combine like terms. Combine like terms. Distribute the negative to both. Combine like terms. Combine like terms. You don't have to have that 0 there, so it's just 12i. And same thing here, 3's combined to 0, 9's combined to be 18 because you're adding. Now we're multiplying. But before we get into multiplying, let's talk about this I unit. I represents the square root of -1. If I have I squared, that represents square root of -1 times the square root of -1. Just like how if I had square root of 2 times square root of 2, I can multiply those together to get the square root of 4. The square root of 4 is equal to 2, like that. In that same aspect, I can do square root of -1 times square root of -1. Square root of -1 squared, because that's the same thing as if I were to square this. You get these two cancel each other out, and that is equal to 2. It's that same thinking process right here. When you're taking the square of something that's the square root, these two cancel each other out. So if I have I squared, it's equal to -1. I squared is equal to -1. If I had I cubed, that would be equal to -1 squared times I, which is also going to be equal to -I. If I had I to the 4th, that would be equal to -1 times -1, which is equal to 1. I will go into this more deeply, especially these two, but I squared is equal to -1. I need to know that for when I start multiplying. So for question A, it's the same type of thing. You distribute here. So 3i times 5, the 3 times 5 gives me a -15, and I have an I. 3 times 2 gives me a 6. I times I is I squared. This right here now switches to be a -1. So now I rewrite this as my real number out in front and my imaginary number out back. Same thing here. I have a binomial, so I'm going to just do it by box method. You can definitely do it by first, outside, inside, last, but just so that I can keep it nice and organized, I'm going to do it box method. 4 times -1 is -4. -1 times 3i is -3i. This becomes -8i. Now this becomes -6i squared. So now when I write this out, I'll have -4 minus 8i minus 3i. This becomes -6 times -1. I squared is -1. So these two can combine. This right here is actually -6 times -1, because this is like plus and negative. This is actually plus 6. So these two can get combined. 6 plus -4 is 2. -8 minus 3 is -11i. I want you to try to do the other 4 by yourself, and you can do it. You're smart. I believe in you. So pause the video and attempt them. So other way you can do this, remember, make sure you do first outside, inside, last. You get 37. Pause the video and check your work if you didn't get the same as me. 7 times 3 is 21. I times I is I squared. Remember, I squared is -1. So -21. You can always still do these by the box method. That's the only reason. You can choose which way you want to do it. First, outside, inside, last. Simplify 23 minus 2i. And finally, here, these two cancel just like these two. Oh, that's weird. Maybe we'll talk about that later. Hint, hint, nudge, nudge. And we get 41. And that is it. That is part 1. You have a great, grand, wonderful day.